The brake system plays a vital role in safe motorcycle riding. In this video, we will study the construction and working of various brake systems. Principle of braking system. Let us look at how braking force is generated. When the brake is operated, the force that works to stop wheel rotation, that is, braking torque, is generated. When the wheel's rotational speed is decreased by this braking torque, frictional force is generated between the road surface and the tires of the motorcycle, which have forward inertia. This frictional force works as a braking force which decelerates and stops the motorcycle. Now, let us take a closer look to how to stop a motorcycle using a small experiment. When something is forced against the rotating rotor, the rotor decelerates and eventually stops. This is because the slipping surfaces generate friction and the rotor's kinetic energy is converted into thermal energy. First, let us look at the construction and operation of the drum brakes. A drum brake is a simple construction and is easy to maintain. For this reason, drum brakes are adopted in many types of motorcycles. The brake shoes have brake lining made up of high frictional material. A brake arm and a brake cam expand the brake shoes. Shoe springs squeeze the expanded shoes. The parts are held by a brake panel. The brake drum fits in the wheel hub. These parts make up the drum brake. When the brake is operated, the motion is transmitted by a cable or a rod to the brake arm. The brake cam is turned and this expands the brake shoes. The shoe which is expanded in the direction of the drum rotation is called the leading shoe. The shoe which is expanded opposite to the direction of the drum's rotation is called the trailing shoe. When the brake is operated, the leading shoe lining comes in contact with the brake drum. The brake drum then drags against the leading shoe, forcing it outward. The lining is thus pressed against the drum with the force stronger than just the cam's force. This effect is known as self-energizing and it provides a large braking torque with little operating force. Let us study the self-energizing effect using an experiment. By establishing a situation where brake operating force remains constant, we can study braking torque. How about in the case of a trailing shoe only? How about when using a leading shoe only? Now you can see that when only the leading shoe is used, the wheel stops in the way. Also, the wheel needs greater weight to rotate more. In the next experiment, let us study the frictional force change when temperature is increased. Here, we have a plate and a weight on a steel board. Let us compare the difference in force needed to slide them at different temperatures. In the first situation, the steel board and the lining plates are cold. What happens when they are hot? The plate starts sliding with a little force. This is because the friction coefficient is decreased by heat. This is described as fading. To prevent fading, the cast iron made drum is cast welded into an aluminium hub for better thermal conduction. The brake lining is designed to provide good frictional force and not to lose this force even when hot. These are the anti-fading and anti-wear characteristics of the system. Next, let us look at the disc brake. Disc brake consists of the following parts. These are master cylinders, which convert brake lever or brake pedal operating force to hydraulic pressure. These are brake calipers, which work by hydraulic pressure from the master cylinders. The brake pads are made up of frictional material and are installed in the brake calipers. The brake disc rotates together with the wheel. First, let us look at the construction and function of the caliper. Pistons and piston seals are incorporated in the caliper. The caliper is fixed rigidly against the disc rotational direction and can slide freely in the thrust direction. Thanks to this self-adjusting system, the hydraulic disc brake doesn't need any adjusting work for brake lever and brake pedal, free play due to pad wear. The system provides constant stabilized braking. Most disc brakes use a hydraulic operating system. Hydraulic pressure is transmitted from the master cylinder to the caliper in accordance with Pascal's law. Pascal's law states that when the pressure is exerted on a confined liquid, it is transmitted undiminished. According to this law, two connected cylinders of the same size balance each other. Next, let us take a closer look at master cylinder, which generates hydraulic pressure. The inside of the master cylinder is made up of a cylinder and a reservoir. These two chambers are connected through an inlet port and a return port and are filled with brake fluid. Finally, let us learn something about brake fluid. Brake fluid is made up of a chemical compound known as glycol, plus some additives to give it anti-rust and lubrication characteristics and to raise its boiling point. Let us heat the brake fluid. Brake fluid has a high boiling point to prevent boiling due to the heat generated by the braking. Let us add some water. Brake fluid has a tendency to absorb moisture. After long-term use, the fluid absorbs moisture from the air. Its boiling point then drops, as shown here. When brake fluid boils, a phenomenon called vapor lock occurs. Vapor lock produces bubbles. Because the fluid is pressurized, bubbles in the brake fluid absorb pressure, as shown in this experiment. The result is the brake feeling becomes spongy and the brake effectiveness is abnormal. Brake fluid should be replaced periodically to prevent vapor lock. The brake system provides the reliable stopping power needed by motorcycles. Reliability and stability are important factors in any brake system. We hope this program will help you to understand Hero brake system mechanisms and to service them efficiently.